Hey guys, thanks for coming to our presentation. We're going to present Ray Observability 2.0, how to debug your Ray application with new observability tooling. So before we start, let us quickly introduce ourselves. I'm Sang-bin. I'm a software engineer at Anyscale. I have been working on the Ray core team and recently also worked on observability features.
I'm Alan. I work on the experience team. I work on observability features, and recently I've been working on the public endpoints product.
I'm Chao. I'm a software engineer in Anyscale experience team. I have been working on observability and Anyscale platform.
Okay, so let's dive into our agenda. So first, we're going to talk about how the Ray observability looked like about last year. And we are going to showcase all the new features we developed over the year using the Ray job. Ray job is an offline workload, basically something like training or batch inference. And Alan's going to demo how to debug Ray server application. And for the missing part that our dashboard cannot solve, Chao's going to explain how to solve these how to support the production use cases using Anyscale as an example. So as many of you here already know, debugging distributed system is very difficult. Why? There are more than three reasons, but three main reasons. Firstly, there are a lot of concurrent tasks running in the cluster. And of course, there are a lot of different failures, from application to hardware failures. And it's also a very large scale, which means whenever something fails, it's going to be so much more difficult to find the problem and solve the problem. Which basically gives us conclusion. The good observability is a key feature for distributed systems. And of course, for Ray, which the goal is to simplify distributed systems. So let's see how Ray observability looked like when we have Ray 2.0, like about last year, about the same time. We had another presentation last year. We had a Ray dashboard that shows the snapshot of the hardware resources, the list of like machines and also processes. We had the log viewer, which allows you to access all different logs in the cluster. And we had a Ray State API. It was a new tool at the time, which allows you to access task, actor, or any other Ray resources through CLI. And we had other tools such as Debugger or pre-built metrics or like integration to Prometheus and things like that. However, although all these tools exist, they're all designed for very domain-specific purpose. And we found many users who had really hard time debugging end-to-end problem because because of lacking UI, and you have to like jump around different places to debug the problem. So our UX designer, Huawei, he's like right there. He did a lot of user research, like talked to tens of users, and we basically figured out that it's extremely critical to make the Ray dashboard as an all-in-one observability tool that provides the seamless UI experience at scale. And that's what we built over the year. And let me try now demo using this fine-tuning workload that we took from the Ray website. So we are going to fine-tune the stable diffusion model using a technique called Dream Booth. And the goal is very simple. We just give the image of this dog on the left side, and we're going to run fine-tuning. And the goal is to basically generate image of dogs using stable diffusion. And there's going to be some failure, and we're going to debug using new features. So the workload, in a glance, is that we first just read images, very simple, and transfer the images. And we're going to run the trainer, 4 of them on GPU, and all these images are going to be fine-tuned. And we're going to generate, of course, the model and create images. So here we are going to demonstrate some of the new features. We built a lot of new features, so we didn't have enough time to demonstrate everything. So we are going to specifically focus on how to debug out-of-memory error using the metrics page and also the memory profiler. Okay, for the demo, we are going to use the Anyscale workspace as an environment. So Anyscale workspace is a development environment that helps you to take the cloud resources and also gives you make it easy to run Ray by providing like EFS, a Jupyter notebook, and things like that. So this is our script. It's pretty simple. We first get the data. It's going to use Ray data under the hood. And we're going to use the torch trainer with 4 GPUs. train function. I'm not going to dive deep into how to do fine-tuning because that's not the goal of the talk. But if you're interested, you can go to the example gallery and find exactly the same code. So let's run this workload. Okay, the workload is running now, and we are going to the dashboard. So this is the newest dashboard you can find from Ray 2.7. When you get into the dashboard, you can first see the cluster utilization, which shows you the utilization of all different hardware resources, and a list of jobs that are running in the cluster. And you can see our train.py, it's the fine-tuning workload, is running. And it shows other high-level information, such as how many nodes are there in the cluster, the output of Ray status, how many demands are there in the cluster, and also the list of events, autoscaler events, application events, and etc. Other noticeable improvement we made is we have a tighter integration to Ray State API, which means all the different resources in Ray, like the jobs, actors, tasks, their metadata and the state is accessible from the dashboard. And as you can see the entry point. The job is actually running. There are like some tasks running for like 1 minute and 50 seconds. There are like other features like actions. You can actually obtain like a stack trace, flame graph, and things like that. You can try later. So you can go to more detail by clicking the ID. And this shows you the progress bar, which shows all the task actors created from this job. You can actually see some of task has been failing. You can see on the right side, there was red. And you can go to the actual task. And you can see actual error message from the dashboard. As you can see from here, it failed by out of memory. And there are a lot of map batches running concurrently that uses about 8 GB of memory. So let's further debug. Let's go to the metrics page. It shows all the pre-built metrics, such as like what kind of task is running, what tasks have been failed by this out of memory error. So you can see there's a split single block has been failing. Or it shows many other very useful information, such as what's the logical allocation of the cluster, like resource allocation of the cluster, how many placement groups are in the cluster. Or for the most important feature today is it's showing you the hardware resource utilization. So you can see the memory usage has been very high. So in order to further debug, let's actually go to the Grafana page. The previous page was powered by Grafana. And you can go to this memory usage by component. And from here, you can see there has been a lot of train workers. So we have 4 train workers using about like 4 to 5 GB of memory. And there was also map batches using 6 GB of memory. And this is snapshot, so there might be like even more up and down around this time. And that's why there was out of memory error. So to further debug, we're going to first debug why train worker uses a lot of memory. So in order to do that, let's go to the script, and we're going to use this open source tool called Memray. So Memray is the open source tool developed by Bloomberg, and it's very good. They track all the Python allocation, and then gives you a flame graph or other sort of report. So you can just simply call this tracker enter in the beginning of the train function. And we're going to store the result into the log folder, which means that since we provide the log viewer, you're able to access all this profiling file inside of our dashboard. So you can see workload is running again, and let's go to the log page. The typical workflow here is you can download all these profiling files to your local machine and just run the Memray command. There's a command called Memray flame graph. But since we're already in workspace, you can just run directly in the terminal. So I'm just going to run Memray flame graph and the path to the memory profiling file. And this gives you all the allocation information here. And as you can see, most of memory usage has been just used by load models. So you just loaded models, and they had to use some RAM. And that's the basically primary usage. And you can see there was no memory leak or some inefficiency or something you can optimize from train workers. So here, as a solution, what we can do alternatively is, since we know map batches has been using a lot of memory, we can simply schedule less of them at the same time by reducing the parallelism. Or other simple solution is you can use like same number of GPUs, but a machine that has more RAM here. Okay, so let's recap. So we demonstrated some of the new dashboard improvement we made after Ray 2.0 for the last 1 year. And also we demonstrated how to use some of new features to debug some simple out-of-memory errors. Okay, so from here, Alan is going to talk about the Ray serve observability.
Thank you, Sang. So my section will be talking about some of the observability we built for our AI libraries. In this case, I'm focusing on RayServe. So first, just to give you some context of what is RayServe. So Serve is an AI library for building model serving APIs. It's built on top of Ray, so that means it can easily scale to many, many machines. And because it also supports Ray's primitives, it's like tasks and actors, it's super simple to create complex or flexible architectures like many model serving or model composition. So I'm also going to introduce two main components about RayServe just to give you more context of the demo. The first is a serve deployment. This is more or less a Python class that you can define that will implement the behavior you want for handling a request. The second concept is a replica. This is an instantiation of your deployment. It's a unit of scaling for RayServe to create copies of your deployment. And it can add and remove copies to handle an increase or decrease of traffic. So why is observability important for RayServe? Well, the first thing I mentioned was that this application is serving APIs to your users or to other services. So it's very important that your application is running at all times. And to do that, you really need observability into understanding the health of your application. The second thing I mentioned was like services often run for long periods of time. So having time series data and metrics can help you understand historical trends and can also help you diagnose past failures. And I mentioned that Serve enables complex architectures such as multi-model serving. So as your application gets more complex, having specialized tools can be very useful in understanding how your application works, which will help make the development and the debugging process just much more smooth. So to demo some of these observability features, we will be demoing a large language model serving application on top of RayServe. We'll be using an existing code base, which is Ray LLM. This is previously known as Avery, but this is an open source project that we've created to make it super simple to deploy open source large language models. It's built on top of RayServe, so it has a bunch of the features I mentioned in the past, like multi-model serving and auto-scaling. And it comes out of the box with support for all the most popular open source LLMs like Llama 2 and Falcon. So over the course of the demo, we'll be doing an overview of some of the Serve observability features. We'll debug a GPU resource availability issue. We'll observe some auto-scaling. And finally, we'll look at metrics and custom metrics. So here I have an Anyscale workspace with my Ray LLM code checked out. The first thing I'm going to do is run my serve application, do serve run, and give it this serve YAML. So this serve YAML is a configuration file that just tells serve the shape of application I want to run. In this case, I have 3 deployments. I have the router deployment, and I have 1 deployment each for the large language models I'm trying to serve, Llama 2 7B and Llama 2 13B. And where the Ray LLM code base comes in is to serve these large language models, I just have to provide it these model YAMLs. You can see I linked to this Llama 2 7B model right here. And with just that one line, I have the open source model serving. So we just quickly look at what this YAML file is. It just has some information that helps Serve understand how to run this model, things like where to download the model weights from, how to scale, how much requests a model can handle, what GPU to use, just various configurations like that. So I've been running the application, so let's see how it's doing. So I open the Ray dashboard and go to the Serve page. So this is one of the new pages we built for the Ray dashboard, targeted towards RayServe. This page is designed to, at a glance, give you an understanding of the health of your Serve application. So at the top, you see a high-level summary of a couple of the Serve components. We have a couple of system components, like the controller and the HTTP proxy, but there's also some information about your own application. And here we can see that 2 of our deployments are still deploying. So as we scroll down, we see that there are 3 deployments. This is what we've configured from our YAML file. We can see that the Llama 2 7B and the Llama 2 13B, it's taking a while to deploy. about a minute and a half. So let's try to figure out what's wrong. So I'm going to go to the overview page, which will let me use the events component. So this component is used by Ray to give information to users that might be important. So in this case, the autoscaler component is giving us information that it's trying to launch a P4D 24x large instance. And if we scroll a little bit further down, we can see that this isn't the first attempt. In the previous attempt, it actually errored. And you can see there's this event right here that there's a insufficient instance capacity error. We do not have sufficient P4D 24x large capacity. So we'll scroll up and see the resource status to kind of understand why we're trying to launch that instance. We can see the status here is that we're looking for an A100 GPU. So this is actually a super common problem with deploying large language models, is it's very hard to get A100 GPUs. And the way we're going to fix this is we're just going to actually change this to use an A10 GPU instead. We do know that Llama 2 7B can run just fine with the A10 GPU. So we'll restart the serve application and give it a few moments. OK, so let's see how it's doing. We'll go back to the Ray dashboard, and we'll go to the serve page. We can see right here that the deployments have indeed restarted. The duration has reset to 0. And in just a few moments, we should see the Llama 2 7B model start running. OK, cool. So it's working. And we'll go ahead and send some test traffic just to verify it works. So I'm just going to run a simple script I have here. It's just querying my local service and asking Llama 2 a question. What are the top tourist attractions in San Francisco? And here we can see that Ray LLM does support streaming. So it's streaming back some response from Llama 2 7B. And it's giving us quite reasonable answers to this question. So things are looking good. So we're going to start sending more traffic to this service so we can see some auto-scaling. So back at the Ray dashboard, I click into the detail page, and we can see more information about this serve deployment. Here we can see a list of the deployments and the number of replicas. We have 1 replica right now, but pretty soon we should see a couple more get added. And yeah, so now we're up to 3. So the way this works is as these replicas receive traffic, they may start queuing if the traffic can't get handled. And if Ray Serve sees enough requests being queued, it can decide to add more replicas to handle the traffic. So it's added 2 more replicas, and they're now running. So things are looking good. So we'll jump forward a couple of hours. So this is 3 hours later. We've been sending traffic. And if we scroll down here, we can see these metrics. So an important part of the health of your application is not just whether your application is running, but if it's actually handling the traffic correctly. So we have metrics right here to give you some good information of how it's doing. So here, these are all a bunch of metrics that come out of the box supported for every Ray Serve application. These are general metrics that we think are useful to understand the health of your application. Things like QPS, error QPS, latencies, even some hardware level metrics like CPU usage and node network. But as an application developer, it's actually pretty important that you want to look at business logic metrics as well. So we do have support with your custom metrics, where you can create custom metrics using Ray Core's metrics library. And with Grafana, you can easily visualize those metrics. So because we are using a pre-existing code base, the Ray LLM project, there is some custom metrics that come out of the box. And we'll just visualize those metrics super quickly here. So what I'm going to do is do a graph for the amount of tokens per second being generated per model. And if I just add the query here and set up the dashboard, we can see quite easily we've added a custom chart right here that can give us understanding of whether our application is running correctly or not. Cool. So to give a quick recap, so some things I showed you, I talked about Ray Serve. It's an AI model serving library, and it scales easily with an increase in traffic. I also showed you Ray LLM, which is an open source project that makes it super simple to deploy open source LLMs. I've showed you some built-in observability features, so you can easily understand the health of your service, and you can also use it for debugging application or infra-level issues. And finally, with custom metrics, you can easily define what healthy means for your own application. Thank you. I'll transition to Chao, who's going to talk more about what it takes to serve in production.
OK, thanks, Alan. OK, so now we have already talked about how you will use Ray dashboard to develop, understand, and debug your machine learning application. So in this section, we're going to talk about what's missing for observability in production use case. We will introduce 3 challenges here in your production use case. And for each of them, we will talk about the pluggability that Ray offers to help you tackle those challenges. And we will use the example of how Anyscale platform address those problems. So when you want to shift your workloads to production use case, there are at least 3 challenges you need to care about: persistency, logs and metrics discoverability, and cluster management. We will talk about them one by one. The first one is persistency. So let's imagine a scenario here. Let's say at the end of the day, you submit a Ray train job to train your text generation model. You know it will take several hours to finish, so you want to check the status next morning. However, in the middle of it, your head node's queued. So the next morning, you found that your logs and metrics are lost. So Ray dashboard don't have the persistency for the logs and metrics by default when your head node is terminated. So that's why logs and metrics should be accessible after your head node is terminated. And you can discover from this diagram, Ray exports 3 different data: logs, metrics, events, so you can easily set in some config and store in your own persistent storage. Like you can use Amazon RDS or S3. And let's jump into detail of how Anyscale platform achieved this. So in the left side, you can see the blue box represents the Ray cluster. The green box in the right represents the Anyscale platform. And the red box in the bottom represents our external users. So the Ray cluster will write the logs into the file system. Anyscale daemon process belong to the Anyscale platform, will read the logs and push them to S3. So for the external users, they can use SDK or API to query and download the logs by directly reading from S3. OK, so second challenge is logs and metrics discoverability. So you should allow some tools from third-party providers to support querying and alerting to have a better understanding of your persistent logs and metrics. So Ray exports logs and metrics, and you can easily read them into the third-party tools like Grafana, Datadog, and Prometheus to achieve the functionality like querying and alerting. And let's have a look of how Anyscale platform achieved this. So you can see from this big box here, the Ray cluster will serve the API to collect and generate the metrics. They also produce the Grafana dashboard configuration. And Anyscale daemon process will read those data and push them into our Anyscale system. The Prometheus will collect the data and transform into time series data. And the storage is backed by disk. The Grafana will fetch those data and visualize them, available in the UI for the user. We also set the alert strategy by PagerDuty. And lastly, let's talk about the cluster management, why it's so important. So when you want to run your workload on your cluster, there are several things you need to care about. First is instance management. You need to grab the cheapest resources in the red availability zone regions from the red cloud provider. You may also need to deal with the spot instance to save money. And second is dependency and deployment. So you need the environment's preparation on each instance to installing the dependencies and your code. And as you can see, those events or say informations may correlate with each other. For example, if you are using a spot instance, and at some point this instance is unavailable, will leading to some application failures of your Ray job, like the task failure. So that's why we need an all-in-one view that consolidates all the cluster-related events. And you can see the Ray exports logs and events, and you can easily to integrate into your own system. You may also have some customized events like related to your own business logic, and you need an all-in-one view to understand them and debug your application. And now let's have a recap of our presentation today. So first, we show the improvements in Ray dashboard and end-to-end user experience in debugging Ray job and Ray serve applications. Second, we showed how production-grade observability could be built by consuming the data from Ray. And one more thing here. So we are excited to announce that we're going to hold a tech office hour to answer the questions from you related to the observability. So the time is on Tuesday, 2:30 p.m. bi-weekly. You can feel free to scan the QR code here to join the Slack channel. And that's all of our topic today. And thanks everyone for coming. We do have several minutes for the QA here. I will hand over back to Sam.
My question would be, are these integration points pluggable? So if I have my own enterprise way to dealing with logs, events, and so on, can I write my own custom plugin to send events to Kafka or send logs to Splunk? How does it work?
Yeah, I can. So yes, these integration points are pluggable. I think they all have schemas at this point, or the API will either be for logs, for example, be a file-based API. So knowing the right directories to sort of save those files, you can push those logs into whatever third-party integration you want. And for things like events, we do have like a protobuf that defines the structure of those events, and you can import those and do whatever you want.
Hi, I would like to know, do these tools also work with on-prem machines and the instances managed and self-hosted, or it's one or the other, or managed services can also watch your on-prem services?
Yeah, sure. So the Ray dashboard works on all clusters. If you run it locally on your laptop, or you run it on an on-prem machine, or use a cloud provider, it should work. For some of the integrations like Prometheus or Grafana, for example, it will absolutely work, but you kind of have to set that up yourself. So if you have it in the cloud, you need to run those services.
Any other questions? We can take one more.
Thanks for the great talk. My question is, does it support automatically deleting all logs?
Sorry, can you repeat the
Yeah,
question?
the old logs, say, if I've been running it for a long time, I have been collecting a lot of old logs. Does it have support to automatically deleting them?
That's deleting. Like, there's some log rotation support, right?
Oh, so Ray has some like built-in log rotation for some of the components, but not everything is automatically deleted. So what we are doing at Anyscale is we deploy the log rotate, like a Linux command, and then we are there's an option called like copy truncate, which you basically rewrite like create a new file and start writing the new log into the new file. So we haven't written that to our official documentation, but we plan to write it very soon. So you're probably going to be able to use the same config and delete all the files, so you can avoid disk. Disk usage.
Sounds good, thanks.
Yeah.
All right, that's the talk. Thank you, everyone. Another hand for our fine presenters.